All right, this is a fun one. We're going to start out here by talking about what is a polygon real quick. A polygon is a straight-sided closed figure. It could be concave, okay, but it's got to be closed, it's got to be straight sides. That's a sloppy one, of course. But one of the big ideas with the polygons here is that we're going to be able to go from the vertices. I'm going to make convex ones just for the simplicity of it. And let's say you have a hexagon. Okay, 6 sides. Well, if I wanted to split this up into triangles, I could pick a vertex and I could draw a line to all the other vertices that aren't already connected to it, like this. Okay? And when I do, you'll see that the number of triangles that we get is exactly equal to the number of sides minus 2. Okay? We have a 6-sided figure and we have 1, 2, 3, 4 triangles when we make it up. And notice this. All of the angles in these triangles are part of the angles that are the angles of the polygon. So like if I said those 4 angles added together equals that same one large angle right there, right? And then there's another angle that's here, there's another angle that's here, that's this one plus this one together makes that large one, etc. Okay? So the result ends up being that you get all 180 degrees in the triangle as part of the angles of the polygon. So now let me start over and I'll just make it clear and refresh this. So check it out. Again, if you start at one vertex, let's say I make a pentagon this time, okay? Like that, okay? If we start at one vertex and we make the connect that vertex to all the other vertices that aren't already connected, and as you can see here, it's already connected to that one, so we don't need to draw another line there. We get 3 triangles, and all the angles on each triangle together make the angles of the polygon. So if we have 180 degrees total in this polygon, and 180 degrees in this polygon, and 180 degrees in this polygon, the sum of the angles in this polygon is equal to the number of sides, 5, minus 2, and then we get that many groups of 180. Okay. Now if we had 6-sided, we'd have 4 total because you'd have 6 sides minus 2. And essentially what we have is the number of sides that we have in the polygon, which we're going to just call n. If you take away 2, that's how many triangles you're always going to get, and then each one is going to contribute 180 to the total sum. So what you get is the formula that they've got here for the sum of the measures of the interior angles of an n-gon, meaning whatever polygon that's got a name that represents the number of sides it's got, is the number of sides minus 2 times 180, okay? And if you like, you can experiment yourself with drawing polygons and splitting them up from one vertex to see how many triangles you get, and then saying, okay, it's going to work out to be always 2 less than the number of sides. So I'll do it one more time so you can see it. And we can even do it with a triangle. Okay? If we have started a vertex, we've already got the 2 sides connected, so we don't have any more triangles. We've just got the one triangle. 3 sides, minus 2 is 1. 1 times 180 is 180. That's how many in the triangle. And if you had a quadrilateral, we could do it like that. You get 2 groups of 180 because 4 sides minus 2 is 2. 2 times 180 is 360. And you should already know that there's 360 degrees total. If that was a rectangle, they would be all 90. But either way, it adds up to 360. Okay, that was a long explanation, but it hopefully gets your mind around it. So now we'll move fast through these. What is the sum of the interior angle measures of a heptagon? We need to know what a heptagon is. A heptagon has 7 sides. Okay, so if we use the formula, we say then, the number of sides in 7 minus 2 ends up being 5. 5 times 180, 900. No matter what it's shaped like, whatever each individual angle is, the total number of angles is going to be, or the total number of degrees in all of the angles is going to be 900. Okay? You just use that formula. Number of sides minus 2, that many triangles, 180, okay? And here they tell you what is the sum of the interior angle measures of a 17-gon. You'll see it written like this, where there's no name particularly for a polygon with 17 sides, so they just do that. It's 17-gon. So you're going to put 17 there, you'll solve it out like that, okay? And the sum of the interior angle measures of a polygon is 1,980. How can you find the number of sides? Puzzle this out, and we'll come back and we'll talk about it. Okay, so here's what we do. We say, okay, the sum is going to be equal to n minus 2 times 180, and I put brackets because we're plugging in parentheses here. That's 17, becomes 15 times 180. Now I just wanted to show you a quick trick here that I've shown other classes to do this if you wanted to do this in your head. And then we'll get to the answer and we'll move on. But if you take half of one number and double another number, when you're multiplying, you get the same amount. For example, if you had 10 times 12, okay, you get 120, obviously. Okay, you could take half of this and double this, 5 times 24, and that also equals 120. Okay, and if we said, what if I wanted to go the other way? I would double this to 20, take half of this to 6, and 20 times 6, also 120. You're always going to get the same number, okay? Who cares, Massey? Well, I care, and you care too, because we can do this in our head if we take these two numbers, and we say 15 times 180. That's the same as if I double 15, I get the nice neat 30, and if I take half of 180, I get the nice neat 90, and I can do 3 times 9 is 27, and there's 2 zeros to add on to it, and you get 2,700 degrees total is the sum of the angles in a 17-gon, okay? True. And that's, by the way, that's degrees right there. That's what I wrote. So that's the first answer. That's A. Okay, now what about B? How do you find the number of degrees in the polygon if they said the sum was 180? Well, if the whole thing is written as this right here, then, and we know what the sum is, we can then say, okay, the sum should be 1,980 equals n minus 2 times 180. And then if we want to solve this, we can divide both sides by 180. Like that. Whoops. I'll do it in red so you can see it. Divided by 180. 180. And what you get is 11. Oops. 11 equals n minus 2, and when we add 2 to both sides, you get 13 is the number of sides. Okay, that's running out of space there, but that's how you do it. So if you know what the sum is, you can put it in the spot where the sum goes, like I did here, and then you can undo it in order to find out what n is. In this case, it's 13. Okay, now, let's talk about what we know. An equilateral polygon, lateral means side, so equal measure sides. Once you get more than a triangle, you can have equal length sides, but the angles aren't all the same, okay? So we have equiangular things that can be all the same angle. Now you notice that this has all the same angle, but the sides are different lengths, okay? When you put those two together, it's equilateral and equiangular. That's what we mean by regular, okay? We have a very standardized, you could, like, no particular part looks or measures differently than the other part. You can kind of rotate it, and it keeps looking the same. It's both equilateral and equiangular. Got it? Now, the corollary to the polygon angle sum theorem is this. If you know that some n-gon can have the total number of degrees be n minus 2 times 180, and you know that because it's regular, those number of degrees is split up equally among the number of angles, which happens to be the same as the number of sides, you can then say, I can find what each interior angle should measure by taking the total number of degrees and dividing it equally into that many angles that it has. And we'll apply that in just a moment. Okay, so here we have this common housefly, Musca domestica. It has eyes that consist of 4,000 of these little regular hexagons, okay? And what is the measure of each interior angle in one hexagon facet? What's the measure of each angle here, okay? Now, how does the word regular help you? You know that each angle measures the same. So if we can find out how many total degrees in a hexagon, we can split it equally among those 6 angles. Got it? By the way, this happens in nature a lot in bees when they make their hives, their honeycombs, etc. Because hexagons, regular hexagons, fit neatly together with no space, right? You can just see that they tessellate together like that. So anyway, what are we looking at here? If we have the formula n minus 2 times 180 divided by n, and we say, okay, we've got 6 sides, and essentially 6 minus 2 is 4, so we have 4 triangles. If we were going to split this up into triangles from one vertex, you would end up forming 4 triangles, which would each contribute 180 to the total, so we said 4 times 180, and what we get there is 720 total degrees. Those 720 degrees have to be split up equally among the 6 angles that are there. So you divide the 720 by 6, and you get 120 degrees in each angle up here. Yeah? That's the big idea. Okay, so here's your got it problem. You're going to try and do the same thing here. Okay, so I've done you a favor here, and I've left the formula. But here it is. What's the measure of each interior angle in a regular nonagon? This means 9 sides. So you're going to calculate this out and see how many degrees in each interior angle, which would be like this in here. Okay? Do a minute, spend a minute on that, and then we'll come back and check your answer. Okay. Now I've written part of this out. I'm going to show you a quick way to do the rest. But first thing, I plugged in here that the 9 for n twice, where it goes in the formula, okay? So what you get is 9 minus 2 times 180, all divided by 9. 9 minus 2 is 7, so you've got 7 times 180 divided by 9. Now the reason I left this here and I want to show you this is because we can divide the bottom and this top number both by 9. Nice and neat, right? You get a 1 on the bottom and you get a 20 on top, because 180 divided by 9 is 20. And then essentially all you get is 7 times 20, which is 140, so it equals 140 degrees in each angle. That's your answer. Okay, now this is where you have to think about what they're asking and you have to apply the idea. The question is, what is the measure of angle y in this pentagon? And you know 4 of the 5 angles. How does that help you? You know the number of sides is 5, and there's 4 out of 5 angle measures, so we can actually set this problem up like this, okay, where you say the number of degrees in each angle here sums up to 470 plus whatever this missing one is. And since you know that there's 5 sides and 5 angles, you can say 5 minus 2 times 180, or 3 times 180 is 540. This needs to sum to 540, and the first 4 angles sum up to 470. If we subtract that amount from both sides, we find that that final angle needs to be 70 degrees, okay? Now, my apologies, I didn't realize that my headphones weren't hooked up and it was recording me through the iPad, so the sound should hopefully be a little better. But here is the quadrilateral EFGH, and those are the 3 angles, so you need to calculate what they are supposed to equal and what the sum of these is like you did above. Give it a shot. All right, so I've written out measure of angle E plus measure of angle F plus measure of angle G plus measure of angle H equals 4, the number of sides, minus 2 times 180. And when we fill those in with the numbers we've got, we don't have this one. But that's 2 then times 180, or 360. These sum to 140 58. And when you subtract that from both sides, you find that the measure of angle G is 102 degrees. Okay, on the next slide, you'll see a demonstration of this. What this is basically saying is, if you were to take each side and you extend it out like that, extend it out like that, extend it out, either direction, right? As long as you just go around the same way each time. And you look at then the exterior angles that are formed at each angle. Essentially, each angle and that outside exterior angle need to be a linear pair summing to 180. You'll find that the sum of those angles, no matter what the shape, no matter how many sides, is always going to sum to 360 degrees. Okay, the sum of the measures of the exterior angles in a polygon, one at each vertex, is 360. And you're going to see a demonstration of this on the next slide. Okay, so what you're seeing here is this is an octagon, and you can see the exterior angles here, right? They've just extended the sides out and they said, okay, then that's an exterior angle. That plus that is going to be a linear pair. They do it there. They do it all the way around, okay? And when you shrink this polygon down, you can start to then see that the sides kind of get smaller and smaller and smaller. And what that does is it closes the degrees together to have almost basically a single vertex point, because the polygon becomes so small and it essentially forms 360 degrees. Okay, I'm gonna see if I can pause it right there at the end. Okay, more or less 360 degrees. Now what happens if you change the number of sides? Okay, here's a 5-sided polygon. You still get those degrees forming 360 all the way around, right? I can increase the number of sides to, let's say, 12, and you still get the same thing, okay? All of those angles close up together when you put them all the vertices together, and you get a full 360 degree rotation around, okay? You can experiment with that on your own, but that's the idea. Okay, so what is the measure of angle 1 in the regular octagon at the right? The trick here is that is a regular figure, and so that 360 degrees, remember that we said that it's going to total has to be split up equally among those 8 exterior angles, okay? And of course it's an exterior angle, you can see, so we know it follows this rule. And so you take the number of degrees, 360, and we divide it by 8, because since it's regular, each exterior angle is going to be the same, and you find that each one is 45. Okay, so what is the measure of an exterior angle of a regular nonagon? Solve this out. We'll be right back to check your answer. Okay, so since an exterior angle will measure, in this case, 1/9 of the 360 degrees, okay, you take the 360 degrees and you split it up equally among the 9 exterior angles, and you find that each exterior angle equals 40 degrees, and that's the solution straight away. All right, you should try these lesson check problems. I have the answers waiting for you when we come back. So write down your answers, and when you have your answers, restart the video, and just be sure that you know how to do this. So do this now, do your lesson check problems now, and then we'll check your answers.